are busy investigating a subtle point in integrating over the delta function. So we're going to derive a useful formula now to deal with this subtlety. One of the things that I should say that you can see from the definition that we've got here is that when you work with the delta function, the way you should think about things is that you're always working under an integral sign. So notice in our definition, we've said that the delta function is 0 everywhere except for the point x is equal to a. But at the point x is equal to a, we never said what the delta function is equal to. All that we said is what is the integral over the delta function equal to. And this is always how you should think. You should always think that we're integrating over the delta. So whenever you try to prove a result, you do it by performing the integral. And you'll see an example of that now. We want to derive a formula for the delta function, and we'll derive that by integrating over the delta. Okay, so I want to consider a specific integral. This is the integral that I want to consider. So I is equal to, it is an integral from a to b. We've got g of x, and we've got delta of f of x dx. So completely different variable inside the argument of the delta function, that's f of x, to the variable that we're integrating over, which is x. So that's why this is a useful example to consider. So let's imagine that f of x is equal to 0 at x is equal to x naught. We will also assume that x0 lies inside our integration domain, and we'll also assume that x naught is the only 0. So that means the complete contribution to the integral comes from the point x is equal to x naught. So as soon as I know that's the case, well, I can evaluate g of x at x naught, and it's now a constant, so I can pull it out of the integral. So I hope that that step is completely clear to you. Think about it. Now I want to do the final integral, and I'd like to do this using our definition. The trouble is that in our definition, we're integrating with respect to x, and the variable inside the delta function is also x. Here, the variable inside my delta function is f, and I'm integrating with respect to x. So let's change variables. Let's change integration variable from x to f. And we can do that by noting that df is equal to the mod of df dx dx. I need the mod here because I want the measure dx and the measure df to be positive. So then rearranging a little, I know that dx will be equal to 1 over df dx times by df. Good. So if I look at the integral I, well, I is now equal to the integral g of x naught. I would be integrating from two values of f. When x is a, f is the f of a, and when x is b, then f is the f of b. And then we've got delta of f, and then we've got dx, which is 1 over the mod of df dx df. Now we know that the only place where we get a contribution to the integral is at x is equal to x naught. So I can take this factor associated to the measure and I can pull it out of the integral. So that's the integral that I'm left with. And the point is Now I really am calculating the area under the delta function. The delta function is satisfied at x is equal to x naught. I integrate over that point. So I know the area under the delta is just going to be 1. So this is nothing but the g of x naught divided by the mod of df dx evaluated at x is equal to x naught. So that's the answer for the integral. Now, to get the identity that I want for the delta function, notice that I can also write this integral as it's an integral from a to b of g of x delta of x minus x naught divided by df dx at x is equal to x naught dx. Okay, so this should be obvious to you, but let's just discuss it a little bit. When I'm integrating over x, the entire contribution is coming from x is equal to x naught. So this function of g of x divided by the mod of df dx, I can evaluate both of those factors at x is equal to x naught and then take them out of the integral. And once I've taken them out of the integral of delta of x minus x naught dx is just 1. So it is obvious that this is going to give me the same answer for I that I just obtained. So now I would like to compare. So let me show you which two lines I want to compare. I want to compare this first line. So look at what's inside the green box. I've got an integral over x from a to b, any function g of x times by the delta function of f of x. And I want to compare it to this last line that I've got. Also, I've got an integral over x from a to b. G of x is an arbitrary function. And I've got delta of x minus x naught times by the mod of df dx at x is equal to x0. So by comparing these two boxes, I can obtain a formula. And that formula says delta of f of x is equal to delta of x minus x naught over the mod of df dx at x is equal to x naught. Why are these two equal? Well, both left and right-hand side are 0 if x is not equal to x naught. And they both give the same answer when multiplied by any function g of x and integrated with respect to x from a to b. So this formula is a correct identity for the delta function. Okay, we'll continue in a minute.